Imagine standing on a vast plain of ice that stretches to the horizon in every direction. The ground beneath your feet isn't solid, but rather a shell floating atop a massive, planet-spanning ocean. Far above, the gigantic form of Jupiter looms in the black sky, its swirling storms casting faint, colored light across the frozen landscape. This isn't science fiction, it's Europa, one of the most fascinating worlds in our solar system. Unlike our familiar moon, a dead, static world, Europa pulses with activity and potential. Its cracked, icy surface tells the story of the forces at work beneath, a global ocean containing more water than all of Earth's oceans combined. The interaction between this hidden sea and the moon's rocky core may create conditions eerily similar to those that gave rise to life on our own planet billions of years ago. This is why NASA's Europa Clipper mission represents one of humanity's most ambitious ventures into the unknown. It's not just about exploring another moon, it's about potentially answering one of the most profound questions we can ask: are we alone in the universe? Europa has captivated scientists ever since the Voyager probes first glimpsed its unique surface in the late 1970s. While most moons in our solar system display ancient, heavily cratered surfaces, Europa appeared strangely smooth and young. Its surface is marked by a complex network of lines that crisscross the entire moon, evidence of dynamic processes reshaping its face continually. When the Galileo spacecraft arrived at Jupiter in the 1990s, it revealed Europa in stunning detail. The moon's surface resembles nothing so much as a cracked eggshell, as though something beneath is pushing up, breaking through. In certain regions, chaotic terrains appear where the ice has completely broken apart and refrozen, like pieces of a cosmic puzzle rearranged by unseen hands. These discoveries pointed to an astonishing reality: beneath Europa's ice shell lies a global ocean of liquid water, kept from freezing by the gravitational interactions between Europa and its parent planet, Jupiter. As Europa orbits the gas giant, Jupiter's immense gravity pulls and stretches the moon, creating tidal forces that generate heat within Europa's core, enough heat to maintain a liquid ocean despite the frigid temperatures of the outer solar system. The implications of this ocean are profound. On Earth, wherever we find water, we find life, from the deepest ocean trenches to volcanic hot springs, from Antarctic ice to desert oases. If Europa's ocean contains the right chemical ingredients, could it, too, harbor life? Could alien microbes be swimming in those dark waters, or perhaps more complex organisms clustered around hydrothermal vents on the ocean floor? Enter the Europa Clipper, humanity's first dedicated mission to this enigmatic moon. Named after the swift and agile sailing ships of the 19th century, the Europa Clipper represents the pinnacle of human ingenuity and our relentless drive to explore the unknown. This sophisticated robotic spacecraft is designed to conduct an unprecedented reconnaissance of Europa, performing repeated close flybys of the icy moon to build a comprehensive picture of its structure, composition, and potential habitability. Unlike an orbiter that would be continually bathed in Jupiter's deadly radiation, the Clipper will swoop in for detailed observations before retreating to safer distances, a dance of approach and withdrawal that will yield an unprecedented wealth of data. At the heart of the Europa Clipper mission is a suite of 9 state-of-the-art scientific instruments, each designed to investigate different aspects of Europa's nature. The Europa Imaging System, EIS, will capture ultra-high-resolution images of the surface, revealing features as small as a few feet across. These images will show us the moon's geology in unprecedented detail, from towering ice ridges to mysterious dark material that may have welled up from the ocean below. The Europa Thermal Emission Imaging System, ETHEMIS, will create heat maps of the surface, potentially revealing hot spots where water from the subsurface ocean might be erupting through the ice in plumes, similar to the geysers observed on Saturn's moon Enceladus. The Radar for Europa Assessment and Sounding, Ocean to Near Surface, REASON, instrument will use ice-penetrating radar to look beneath the surface, mapping the thickness of the ice shell and potentially detecting the upper boundary of the ocean itself. The Europa Ultraviolet Spectrograph, Europa UVS, will analyze the composition of Europa's tenuous atmosphere and search for plume activity by looking for specific fingerprints of water vapor and other materials. The Mass Spectrometer for Planetary Exploration, MASSPEX, will sample any molecules it encounters, providing detailed information about their composition, crucial for determining whether Europa's ocean contains the organic compounds necessary for life. Together, these instruments, along with magnetometers, gravity sensors, and other sophisticated tools, will give us our most detailed look yet at this mysterious world, providing essential data about its potential to harbor life. The journey to Europa is a monumental undertaking, spanning hundreds of millions of miles through the cold vacuum of interplanetary space. To propel the Europa Clipper on this epic voyage, NASA has selected one of the most powerful rockets ever constructed, SpaceX's Falcon Heavy. Kindly like, share and subscribe our channel for further more updates about space.